Good. So let's sum up. This is your genotype. That's the information in your genes, in your DNA. The phenotype is what you look like. That's what we said. Natural selection operates at the level of the phenotype. It doesn't operate at that level. That's where chance operates. Chance through mutations. Fine. Let's put that into another model. Here we have a book of instructions on how to build an aeroplane. Okay? Here's a book of instructions with detailed instructions on how to build an aeroplane. The book of instructions in our analogy is what? The genotype. The DNA is a book of instructions on how to build a human being. Isn't that correct? All right. And the phenotype is the actual aeroplane. Now, question. Who wrote the book? Well, who wrote the book? Obviously, some intelligent designer wrote the book in this case, right? Correct? But in our analogy, who wrote the book? Chance. Or as you guys say it, chance. I can say it. Chance wrote the book, just so that you have another accent to contend with. All right, Chance wrote the book. That's incredible. With all the information as to how to build the airplane. Now that's fascinating. That is really monstrous. That's terrific. Let's play this game out. I have a book. Here it is. And let's assume, for argument's sake, that this book has now come into existence by chance, mutations. And all the information for whatever it is we're going to build is in here. In this case, all the information for my aeroplane has now by chance appeared, and here it is in this book. This is great. So now I'm going to take this book, and I'm going to put it down over here on the floor. There it is. It's in my bookshelf. There it is. And now I'm going to wait for the aeroplane to appear. After all, I have all the information. It has come about by chance. There it is. And it's all there. Now, all that has to happen is the aeroplane must come. How long am I going to wait? How long am I going to wait? Well, come on. Forever. I'm going to wait forever and ever and ever. Is it enough for the information to come into existence by itself, yes or no? No. If I don't have a mechanism that will translate this information into the aeroplane, then my aeroplane will never appear. Is that correct or not? Okay. So my book by itself, even if it should come into existence by chance, is totally what? Useless. Thank you. Okay. Now that we've solved that problem, let's think about that. All right. So my book is really useless without a method of transcribing the information into the aeroplane. Now, what do I need to change the information into an aeroplane? You tell me. Well, I need some factory, don't I? And I need someone to intelligently interpret what is in that book so that I can get the aeroplane constructed. So I need some assembly line, and I need some workers. Or if I don't have workers, what do I need? I need tools and machines, robots, if you like, that will do it for me. Is that correct? So, question. Where or how did the design mechanisms get translated? How did the factory come into existence? And how did the robots come into existence that will eventually build my machine so that I can test fly it? According to my analogy, Natural selection will only start operating when once what has happened? The aeroplane's there. So the whole mechanism to convert the information into the aeroplane, how did that have to come into existence? You tell me. You have two choices. Two choices. Because natural selection will only work once the aeroplane is there. Then I can only see, oh, it flies or it does not fly, right? So how did the mechanism come into existence? Give me the choices. The first one is chance. The second one is design. Design. That's your only possibility. Either it's chance or it is creative design. Those are the only two possibilities that we have. Okay, which one does science choose? Chance. Science chooses chance. Good. Now, when we read the DNA, this is a very complex situation. In fact, we don't even read the whole of a gene. We read only portions of it called introns and exons, and the exons are transported and translated and taken outside, and then there is a highly complex factory with robots that changes the information from the gene, in other words, reads it, and then translates it here into another form of messenger, which then passes out through the cell, combines with a structure we call a ribosome, which is an assembly line, a factory, and this factory then manufactures a protein, which in turn is manipulated and folded by another factory and transported, like with a railway system, if you like, to where it is needed and built into place. How did all of that come into existence? Well, we're still not with anything tangible. We're just building something tangible. So how did it come into existence? You tell me. You have two choices. Chance or design. Because natural selection will only operate once the object is actually there. Wow, that's mind-boggling. You want to see what it looks like? Well, let's have a look. Here's an Ilustro Media video, which is titled Unlocking the Mysteries of Life, the Scientific Case for Intelligent Design. You can actually get it at the back. It is sold at the back, and you can have a look at an animation of what happens.
With computer animation, we can enter the cell to view this remarkable system at work. After entering the heart of the cell, we see the tightly wound strands of DNA, storehouses for the instructions necessary to build every protein in an organism. In a process known as transcription, a molecular machine first unwinds a section of the DNA helix to expose the genetic instructions needed to assemble a specific protein molecule. Another machine then copies these instructions to form a molecule known as messenger RNA. When transcription is complete, the slender RNA strand carries the genetic information through the nuclear pore complex, the gatekeeper for traffic in and out of the cell nucleus. The messenger RNA strand is directed to a two-part molecular factory called a ribosome. After attaching itself securely, the process of translation begins. Inside the ribosome, a molecular assembly line builds a specifically sequenced chain of amino acids. These amino acids are transported from other parts of the cell and then linked into chains often hundreds of units long. Their sequential arrangement determines the type of protein manufactured. When the chain is finished, it is moved from the ribosome to a barrel-shaped machine that helps fold it into the precise shape critical to its function. After the chain is folded into a protein, it is then released and shepherded by another molecular machine to the exact location where it is needed.
It came about by how? Chance or design. That's your only option. There is no other. In actual fact, what you saw in this animation is highly, highly oversimplified. When you consider what happens in a cell as that DNA unfolds and the enzyme systems that are required to produce this molecule, it is mind-boggling. And when it passes through that nuclear pore, it passes through with such precision that nothing else may enter and leave while this huge molecule is passing from one side to the other. Everything is highly precise with recognizing symbols and all kinds of structures. And one mistake and you're a cabbage. And it came about by chance or design. Because until that protein is actually there, natural selection cannot say whether it will work or whether it won't.